Hello, everybody. I apologize again for getting this to you guys late, but this time it's 12 a.m. and not 2 a.m. Yeah, I shouldn't be proud of that. Anyway, let's get started on this review real quick. It's not going to be that long, but I feel like it's necessary to help you guys out. Um, so, with that, we're going to start off with correlation. What does a correlation help us determine? It helps us determine any relation between or among things. The kind of claim we can make with that is an association. Remember, association is just saying, hey, there's some type of relation between these two variables. We just don't know which direction the influence is going in. The letter associated with a correlation output is a lowercase italicized r. Okay, so for r squared, what does it mean? It helps us determine the amount of variance in a dependent variable accounted for by the IVs that you've selected, the independent variables. The kind of claim this helps us make is, again, an association. Um, you'll see r squared in correlation and multiple regression outputs. Um, this variance, we're just saying that these IVs are affecting this DV in some way. We just don't know how, but we know that these IVs are accounting for the variance. The letter associated with an R squared is an italicized capital R, and then a squared that's not italicized. Okay, three causal criteria. I have the pages listed for you to review it. Covariance, temporal precedence, internal validity. I think you guys should review that. It's very brief and it's pretty self-explanatory. So going on with that, I wanted to talk about the independent and paired samples t-test. They help us determine differences in the mean between our IVs or levels. What kind of claim can we make with this? We can make a causal claim, but we still have to be aware of the fact that we're not able to completely assume that this IV is causing this kind of output for the DV. Independent and paired samples t-tests, they're a little stronger, I guess, when it comes to analyses and interpreting results compared to correlations. So with that, we're going to go on to which letters associated with a t-test output. Hint, I just typed it lowercase italicized t. Moving on, I broke down the differences between independent samples t-test and the paired samples t-test in case you guys wanted a refresher. I have what they look at, like breaking it down into a little more plain English, and then a mnemonic device to help you guys remember. Um, I know my mnemonic device is long, but the fact that for myself I'm breaking it down into very simple plain English helps me remember it a lot better. Multiple regressions, MR, it helps us determine if two variables can still predict an outcome while we're controlling for a third variable that might be associated in this prediction. What kind of claim can we make? Causal, and again, read that warning. Be aware that we can't completely assume causation. Which letter is associated with MR? Capital italicized B. Use this when you're in Debbie's class because that's how she wants you guys to report the beta. And then another letter associated with MR is the lowercase Greek letter beta. It has like this straight back to it. I noticed that when some of you report the betas, that line is like curved upward. Um, Although I will understand, and probably other researchers would understand what you're trying to report, it could still throw people off because they can think you're using some other analysis. So pick this lowercase beta, Greek beta, with a straight back to it. Okay, for ANOVA or analysis of variance, what does it help us determine? It helps us determine the differences in the variance between two IVs or levels. ANOVA can be used when you have more than two IVs. What kind of claim can we make? Causal, again, read that warning. The letter associated with ANOVA is a capitalized italicized F. I made this little table for you guys. There's a lot of helpful information in your textbooks. There are concrete examples, um, etc. So go to pages 485 to 521 in your textbook. Um, and then also there are examples of how to write up the mean and standard deviation in APA format, um, or how it looks in journal articles, and that's on page 449. Okay, so this table, if one of your IVs is continuous and the other is dichotomous, we're going to use a t-test. So dichotomous, think of it as two, di, and then for the next one we have one IV is continuous and the other is categorical. So for the categorical, it's going to create specific categories like one equals um, 1 equals upper class, 2 equals middle class, 3 equals lower class, something like that. So when one IV is continuous and the other is categorical, you're going to use an ANOVA or a linear regression, aka multiple regression. If one IV is continuous and the other is continuous, you can use a correlation or a linear regression. Experimental designs. There's the between subjects, the within subjects, independent samples, paired samples, 2x2 factorial, 2x3 factorial. I'm sure in your guys' textbooks it gets into this in a lot more detail and it gives you some examples, so go ahead and check that out. And then for a reading discussion for this week's lab, please read that second article that's listed under primary source readings. I want you to read it before lab since we'll be having a discussion about it. And I want you guys to come in with questions and I want you guys to be prepared to participate. So this PowerPoint was really short because I want to spend more time on doing analyses. So I'm going to go ahead and open SPSS. Okay, so I have all this random data that I created. I have participant ID, study, gender, age, region, employed, income, condition, esteem, happiness, dogs, Ferrari, Lamborghini, Ferrari post-release, Lamborghini past-release, or post-release, and then T1, T2 for handshake, firmness, and then T1C and T2C is referring to cortisol levels. Okay, so for study, I just want to point out, don't worry about it. It's just to help you understand the data a lot easier. So this is one study right here, and the variables that you see, or the data that are filled up, these are the variables that you're looking for this particular study. So if I switch this, you'll see happiness, dogs, esteem, income. That's what the study's looking at. Study number 2, we have time 1, time 2, Ferrari and Lamborghini. This time 1 and time 2 are corresponding to the PFERR variable and the PLAMB variable. And then for the third study, it's time 1, time 2 for handshake firmness, region, condition, and cortisol level. Condition, cortisol, handshake. Sorry, this T1 and T2 are for the handshake. And then we have our cortisol time 1, time 2. Okay, so I coded females such that 0 is female, 1 equals male. We have for income, we have 1 equals less than 30,000, 2 equals between 30,000 60,000, and 3 equals greater than 60,000. For dogs, we have 0 0 is less than 3 dogs, 1 is more than 3 dogs. For condition, or region, I'm sorry, 1 is north and 2 is south. And then for condition, control is 0, insult is 1. Okay, so now that I explained those variables to you, I'm going to run some analyses, starting off with our correlation. So we're going to go to Analyze, Correlate, Bivariate. I'm going to look at the correlation between self-esteem and happiness. I'm going to go to Options, make sure means and standard deviations are selected. Hit OK. Okay, so this is our output. I am now going to go to Microsoft Word and show you an example of how to do the write-up. Okay, so we have there was a significant correlation between self-esteem ratings and happiness ratings. Then we'll put the the R equals 0.97, comma, P is less than 0.001. I just want to mention to you that this P is less than 0.001. I'm still waiting to find out from Debbie about if she wants you guys to put P is equal to 0.01 or P is less than 0.01. So I'll try to get back to you guys as soon as possible when I find that out. Okay, so we reported that correlation. You can see that that it's a positive correlation. So we have our effect size, the effect size of the results shows a strong effect. And then we'll also talk about the means and standard deviations. We see that the mean for self-esteem is at about 67, and for happiness it's at close to 73. So we're going to say that the average rating for self-esteem among the participants was, or actually let's do this. The average rating for self-esteem and happiness were fairly close to each other. And then we'd include the means. You can do it this way: M equals for self-esteem 67.45, and standard deviation equals 20.80. And then we have the other mean for happiness of 72.90, and standard deviation of 2.20 respectively. Okay, so that's our correlation. If you want to do a brief description of the plain English part, it's the relation shows, or the relation suggests that as self-esteem increases, self-esteem increases, happiness increases, and vice versa. The reason I wrote vice versa is, again, remember this is a correlation, so we don't know if happiness is causing this positive relationship or self-esteem is causing it or influencing it. So I just want to write vice versa because it's going to tell my readers that, hey, if self-esteem increases and then happiness increases, then happiness increases and then self-esteem increases. So it could go either way. Okay, so now we're gonna do that multiple regression and it's r squared. So we're gonna go to multiple regression, linear. I have as my dependent variable the happiness ratings, and my independent variables are self-esteem and the number of dogs owned. Statistics, I have my model fit. This is what you guys have to report for the extra credit and the r squared change. Don't worry about the descriptives and the correlations, so just focus on this part. As for assignment 6, you guys should be comfortable with reporting the descriptives, of course. There's some of you have asked a question, I'll get back to it later, but I'm going to continue with this example. Okay, so we have these in their places, hit OK. We see here that, let me open this window up a little more. We have our correlation that we had already talked about with self-esteem and happiness. There's also now a correlation for happiness and number of dogs owned and self-esteem and the number of dogs owned. If you look at their significance values, happiness and number of dogs owned is 0.02. It's less than 0.05, which means it's significant. And this one is equal to 0.05. So it's almost significant, but not there because it's not less than 0.05. Okay, so going down. We have our model summary here, which gives us our r square. We have our ANOVA. The regression is the f has the f value that we're going to be reporting, and then we have our beta coefficients. So let's start off with the model summary and ANOVA. So we can say, or actually, let's start off with the betas. So we see that for self-esteem, our beta is 0.93, and it's significant at p less than 0.001. So we're going to say self-esteem was a significant predictor. And be aware that when you see or hear or think of the word predictor, think of multiple regression. Okay, self-esteem was a significant predictor of happiness. Self-esteem ratings were a significant predictor of happiness ratings. And then you'd report it, B equals 0.93, and then P is less than 0.001. We have that information. We also want to put the beta for the number of dogs owned. So we're going to write the number of dogs owned were not a significant predictor of happiness ratings. B equals 0.10, p equals 0.14. So since this is greater than 0.05, it's not significant. And don't forget, guys, the APA format, follow it closely. I'm not stating it explicitly, but I'm hoping you guys know by now that some stuff are italicized. There are spaces on both sides of the equal sign, so here and here. And then same goes for p-values, r-squareds, and all that other stuff. Okay, so the next thing we're going to write about is the model summary and the ANOVA. We can say the regression model in the ANOVA output. The regression model in the ANOVA output is significant. F2 and 19. And then we're going to have our F value of 140.63. Our sig values P less than 0.001. Oops, I should have taken off italics. There you go. After you report this, the p-value, you're going to put in the r and then give a brief description of it in the following sentence. Sorry, the r-squared. So there you go. R-squared equals 0.94. Again, there's no 0 in front of the r-squared because the highest number in r-squared can go is 1. So continuing on from that, we can say that self-esteem and the number of dogs owned account for 94% of the variance. Oops, 94% of the variance in happiness ratings. So you're going to have that information. Always include the, if you're just doing a regression output, include the correlations. Talk about the coefficients, the ANOVA, the model summary, and also write the plain English version of what these betas mean. So the way you interpret a beta is the same as interpreting a correlation. However, you'll see that for multiple regression, there's that temporal precedence, the temporal precedence requirement, which means that the IV is coming before the DV, and the DV is a result of the IV occurring first. So, putting this in plain English, you can write self-esteem, predicted happiness ratings, such that an increase in self-esteem could lead to a subsequent increase in happiness. Notice that I'm not saying causing, I'm just saying predicting, and could, meaning other things can happen. So keep that in mind. Oh, and for the dogs, the number of dogs owned did not predict happiness ratings. And you see that the beta for number of dogs owned is 0.10. So you might be tempted to say there's some prediction happening, but there is no prediction happening because it's not significant. So in plain English, you would just put the number of dogs owned, did not predict significant changes in happiness ratings. Okay, oops, fix that. Significant. Okay, next one. We are gonna do our t-test, independent samples t-test. So we're gonna look at first time one handshake firmness. Move it over here. Hit OK. So for our independent samples t-test, we have a t that's not significant. So if you're not going to use a Levene's test for equality of variances, the way to tell that there's equal variances between your groups is to see if at T1 the difference is significant. We see over here that it's not, since P is 0.701. So there's no significant differences in the means. So remember, when a t-test looks at differences in the means, if there are no significant differences in the means, then and this is suggesting that there's no significant difference in the variances. And since there's no significant difference in the variances, you can say that random assignment was successful. Okay, so I'm gonna finish all the t-test outputs, and then I'm gonna write the interpretation. So now we're gonna do time 1 and time 2. To do that, you go to compare means, paired samples t-test, and we're gonna have move these over here. Time 1 handshake firmness versus time 2 handshake firmness. Hit OK. We see that there is a significant difference between time 1 and time 2. And then we have our means and standard deviations, which we're going to need later. Okay, so now we're going to do our final independent samples t-test to see if there's a difference between the two group means at time 2. So handshake firmness goes here. And remember, for the grouping variable minus condition, and 0 equals control and 1 equals insult. So we're going to hit OK. And then we have our other output over here. We see that there is a significant difference since p is less than 0.001. And again, we're going to use a row that says equal variances assumed. So let's start writing this up. We're going to say random assignment was successful because there were no significant differences. Oh my god, I'm spelling that wrong a lot. Differences between the two groups at time 1. And then we're gonna put our t value. So t equals negative 0.39. Then our p value, which is equal to 0.70. Okay, and then we can kind of break this down a little bit more. Significant differences in the means between the two groups at time. Okay, now we can say since there were no significant differences in the mean in this test, we can assume that there were no significant differences in the variance. This suggests that the variances between both groups are fairly equal. Okay, so that's that first part. And then we could include the means also to show the readers. The average handshake firmness at time 1 and the average handshake firmness between both groups at time 1 show or appear to not be significantly different. And then include the means and standard deviations. Equals 4.20, and then standard deviation equals 0.77. And the mean for the second group is 4.30, and the standard deviation is 0.87, respectively. Okay, so the average handshake firmness between the control group and insult group at time 1 appear to not be significant. Okay, so that's that first part. We're going to go to the paired samples t-test. And this time we're going to say we can say there was a significant difference between times 1 and times 1 and 2 in terms of handshake firmness. Then we're going to include our t value. T equals, sorry, let's move this over a little bit and open this up. Okay, so t equals negative 2.31, and the p-value is equal to 0.03. Okay, so, and I've been forgetting to put the degrees of freedom in here, but don't forget for the t values to include the degrees of freedom. So this one is 38. Okay. So now you have that reported. You can go on to the next part of this interpretation. You can say that the average handshake firmness at time 1 so mean 4.25, standard deviation equals 1 at time 1 was less than time 2. standard deviation is 2.18. So that's that part. Going on to the third part, we're going to say, talk about the differences between the conditions at time 2 now. So we're going to write, there was a significant difference between both groups with respect to handshake firmness. And then we're going to report the t-value, the degrees of freedom, which is 38. And remember, we're looking at the equal variances assumed row. Negative 4.14. And the p-value is less than 0.001. Okay, so the average handshake firmness in the control group equals 3.90. Uh, 1.29 was less than the insult group. And then that's going to be 6.30, standard deviation 2.25. And there you go. That's a t-test with your test to see for successful random assignment, differences between time 1 and time 2 for both groups, and then this is going to tell us the t-test for time 2 is just telling us the differences between the groups just at time 2 and not at time 1. Okay, so next thing that we're going to look at is the ANOVA. So we're going to do general linear model, univariate. Already have my stuff chosen over here. I'm going to options, making sure I put the descriptives option, hitting continue, then hit OK. So here's my means and standard deviations, and then my ANOVA output. And just know that one of my IVs had 3 levels, so my output is going to be a lot longer, and I'm not going to be writing up the whole thing. I'm just going to include some stuff as an example. So we see that in our ANOVA that the main effect for dogs is significant. So we're going to put there was a significant effect of the number of dogs owned on the ratings, on the happiness ratings. And then you're gonna include the F value, F, and then for dogs it's 1, then we have our error, which is 14, then 10.75, P equals 0.01. Okay, and then now we're going to talk about the second main effect. There was a significant effect of the income level on the happiness ratings. And then F 2 comma space 14 is 16.30, and the P is less than 0.001. So since all of these p's are less than 0.05, they're all significant. So we reported the second main effect, now we're going to report the interaction. There was a significant interaction between the number of dogs owned and income level. Then we're going to report our F. For the interaction, it's 2 again. And we see our interaction, it's 5.88. And the P is equal to 0.01. So now for our, we're going to do our simple effects tests. So for this one, we're going to have to go to data and do the select cases and all that fun stuff. So go to if condition is satisfied. Let's put if income equals 1. Hit OK. We have our filter. Now we're going to do analyze, compare means, and do the independent samples t-test. Let's move this here. So for our test variable, remember it's going to be our dv. So we're going to move happiness, and then we're going to do number of dogs owned. Define groups. 0 is less than 3 dogs, 1 is more than 3 dogs. So continue. Okay. So we can see that there's no significant difference for the means of for the people who have an income of less than $30,000. So we're now gonna write simple effects tests were conducted to determine where the significant effect or interaction is occurring. Okay, so then we're gonna write there was no significant difference. Let's see. There was no significant difference between owning less than 3 dogs, include our means and standard deviations. Oops, sorry. There was no significant difference in happiness ratings for the low for the participants making less than $30,000. And then we're going to talk about the groups of either owning less than 3 dogs or more than 3 dogs. So for the participants less than 30,000, okay, at this income level, or sorry, we're gonna include the t-values for this. 5 equals -0.07. P p equals 0.95. Oops. Making less than 30,000. For the participants either owning less than or more than 3 dogs and making less than 30,000. Okay, so now we're gonna write up the means and standard deviations for this. I asked Debbie, guys, and she wants you to include, this should be negative 0.07. She wants you guys to include the t-test part when you're reporting the simple effects. On assignment 6, do include the t-values, okay? I'll write that in the message as well, but don't forget to write the t-values for associated with your simple effects. Okay, so we've got that part. Now trying to think of how I can extend this. Our interactions are occurring. Okay, participants either owning less than or more than 3 dogs, as well as, there you go. Okay, now we're gonna say that the average happiness rating for participants owning less than 3 dogs. Let's change that around. The average happiness ratings for happiness ratings for participants making less than $30,000 who own less than 3 dogs equals 57.67. Standard deviation equals 11.85. The average happiness ratings for participants making less than 30,000 who own less than 3 dogs were similar to participants making the same amount and who own more than 3 dogs. So then the mean for that is 58.25, and we have our standard deviation equals 11.56, and then we end that period. So that's one of them. You then continue on to the next one. So I'm going to do data select cases again. Instead of if income equals 1, we're going to do if income equals 2, and then hit OK. And then now we're going to do analyze. We're going to do independent samples t-test again, and then we're just going to leave everything as it is and hit OK. And then we have this output, and you see that there is a significant interaction occurring here for people who make between 30,000 and 60,000. So we're going to talk about that. The simple effects tests showed a significant difference in happiness ratings for the participants making between $30,000 and $60,000. Short and happiness ratings for the participants making between $30,000 and $60,000. And again, I made the similar mess up as before. Participants either owning less than or more than 3 dogs, as well as making between. Okay, long sentence. So, oops, not F. I meant to put T. The degrees of freedom this time is 3. We have our T value is negative 4.04. Our standard deviation, or sorry, not standard deviation, P value is equal to 0.03. So we've got that reported. Now we want to report the means and say the average happiness ratings for participants making between $30,000 and $60,000, who own less than 3 dogs. Mean equals 41.50. Standard deviation equals 9.19. Was less than the participants who own more than 3 dogs. Just gonna copy this and put this up here, making this. Oh, I guess I don't need to. Anyway, mean is 82.00. Standard deviation equals 11.79. So that's the write-up for the significant part. I'm just going to do one more to see if it's significant or not, just to follow through. If income equals 3, analyze, compare means, independent samples t-test. Okay. So we see that there's no significant difference for people who are in the income level of greater than $60,000. So we're seeing that the significant effect is occurring at the income level of between $30,000 and $60,000. So that's the write-up for that. There's one more thing in your guys' assignment 6 that Debbie didn't really make clear to me until the other day on Saturday. So whenever you're doing assignment 6 and you do the same thing for doing the simple effects, you have to switch it now. And by that, I mean, instead of doing select cases if and putting, let's say, region or condition, you're going to have a total of 8 means and 8 standard deviations. So to show you guys how to do that, this is my data that's kind of similar to the experiment. I'm not going to include time 1 and time 2 handshake firmness. I'm going to just focus on time 1, time 2 cortisol levels. So we have our region, north and south, and then we have our condition, control and insult. We'll see that condition 0 equals control, 1 equals insult. And then for, where is it? we have our region as 1 equals north, 2 equals south. So we're going to go to select cases. We're going to go to if condition is satisfied, if condition equals 0, hit continue, hit OK. So now it's in select those. We're going to do our simple effects test of independent samples t-test. Move these guys over. Okay, so condition is our grouping variable. 0 is for control, 1 is for insult. Hit continue. And then we are going to be moving our time to cortisol levels. Okay, so I think in your guys's assignment 6, there's no time 1, time 2, it's just cortisol levels. But just try to follow along with what I'm doing here. Pretend this is just cortisol levels. So hit OK. And I forgot that I have to do the opposite. Okay, independent samples t-test. If we're doing select cases and putting condition, then we have to put the other one. So we're going to look for region. So 1 is north, 2 is south, continue. Okay, so ignore this part. Okay, so we see that there's a significant difference for region at time 1 and time 2. I'm gonna write up the means and standard deviations, and then next you're gonna do data, select cases. If condition satisfied, you're gonna do condition equals 1, hit continue, hit OK, analyze, independent samples t-test, hit OK again. So we have this so far. Now we're going to be switching it up. We're going to go to data, select cases, if condition satisfied. This time we're going to be putting condition equals 0, hit OK. Now for analyze, we're going to replace our grouping variable. We're going to be moving this back, and then we're going to be moving condition to grouping variable. Sorry, I think I'm getting this wrong again. Move region, keep passing it. Okay, so we did region here. Now we're going to be select cases. Excuse me for my error. Put region equals 1. Hit OK. Now do our analyze, compare means, move region, and bring back condition. Hit OK. Again, I messed this up. So, starting up top. Okay, so we had controlled for condition in here, and this is condition 0, so this is a control, and then condition 1, which is insult. So let's delete that. Do our select cases. Again, if region equals 1, and then analyze, compare means, independent samples t-test. For group, this is why I wasn't getting an output, because I forgot to change it. Okay, now hit continue. We see that there isn't a significant difference here, because it's greater than 0.05, which is the standard for which we're comparing to. I noticed some of you made the mistake that if p is less than 0.01, then it's significant. If it's greater than 0.01, it's not. That's incorrect. As long as it's less than 0.05, then it's significant. Okay, so you did this. Now we're going to do it one more time, but instead of select cases, we're going to put region equals 2. Hit OK. And then compare means independent samples t-test. Hit OK. And we see that there is a significant difference here for cortisol levels in the south, comparing control and insult. So on your guys' homework assignment, you're going to be getting a total of 8 means and standard deviations. So for my example, it's only showing up as 4 means and standard deviations, but don't forget to flip it around. When you use select cases, do it first for region and then flip it around and do it for a condition. Okay, so analyze. I'm going to do one more. Univariate. Move this over here. Okay, so RT2, dependent variable, fixed factors, condition, time 1. Okay, so this is a ANOVA that I was just using as an example. You can see we kind of have some means and standard deviations that would be hard to interpret. So I'm going to get rid of this example. And yeah, if you guys have any questions about the assignment, let me know. I'm hoping that this is all helpful for you guys. I'll try to post something that might be helpful if I can find anything, hopefully before tomorrow night or tonight. Okay, anyway, feel free to come to my office hours or email me. I should be quick to replying to my emails up until like 5 or 6 o'clock, so just letting you guys know that. And yes, goodbye.